Hello, everyone. Let's keep learning machine learning, shall we? All right. In this video, I will show you how to use the AWS SageMaker app to run a classification solution to predict whether a person will be diagnosed with type 2 diabetes within 5 years. What's AWS? Well, AWS stands for Amazon Web Services, and it's just kind of Amazon cloud computing offering or platform, okay? So they offer a lot of cloud computing services, and one of them is SageMaker, which is an app that allows us to apply machine learning solutions, okay? Now, in order to use SageMaker to obtain a classification solution or to apply machine learning in general, you need to complete a few easy tasks, all right? Now, in this video, rather than spending time showing you all the tasks that you need to do to have SageMaker ready, I decided to share links with information that will help you easily, very easily, on your own, complete this task, okay? I created this Google Doc right here, which I will share with you in the video description. And in this Google Doc, you have all the steps you need to follow to be able to open SageMaker and kind of replicate what I'm going to do here, okay? Okay, so the first step is, as you can see, open an AWS account and start using services through the AWS console. Um, Opening an AWS account is free, and using some, not all, but some of the apps is also free. Now, for example, if you want to replicate what I'm going to do in this video, you will need to pay a few cents. Last time I did this, a couple of days ago, I did exactly what I'm going to do in this video today. I paid 10 cents, only 10 cents. Okay, so it's up to you if you want to do this or not. But if you want to learn how to use AWS SageMaker to obtain machine learning solutions, you will need to spend a few cents. Okay. Okay, so that's a step number one, and here you have the links how to do it. Step number two is open the SageMaker app. Okay, so once you have an account, you need to open the SageMaker app. Here is how to do it. And after that, once you open the SageMaker app, you need to open a SageMaker notebook instance. So what is a notebook instance? And I wrote this definition here for you. A SageMaker notebook instance provides the computing resources, that means CPU or GPU and the RAM, that support the Jupyter notebook that we will use for data preprocessing, model training, and deployment. So in this video, I'm gonna use a Jupyter notebook, and I'm gonna include all the code to obtain the machine learning solution in that notebook, in that Jupyter notebook. And this is the thing. The notebook instance provides that Jupyter notebook all the processing power and the memory needed for the notebook to be able to load the data, pre-process the data, train the model. Okay. All right. So perfect. So these are the steps you need to follow to create that notebook instance. And after that, the last step is once you open the notebook instance, a you're going to open Jupyter Lab, and then inside Jupyter Lab, you're going to open a new Python notebook. So this is Jupyter Lab right here. So once you open Jupyter Lab, you're going to land in this page right there. And now we're going to open a new notebook from here. Okay, that's step number four. So before we do that, let me mention step number five, which is something that you need to do at the end. And this is very important, guys. After the analysis is over, you need to clean up the AWS resources you used. You cannot forget to do that. What do I mean by that? So you need to stop the instance, delete the notebook instance. You need to delete the S3 bucket that you're going to create. You will see what that is in a few minutes. But anyway, so you need to clean up the resources. If you don't do that, instead of a few cents, you might end up paying a few dollars. Okay, you don't want to pay more than you need to. Okay. Anyway, so clean up the resources and following that link, you will easily understand how to clean up the resources. Great. All right. So again, I'm going to share this Google Doc with you in the video description. Now I'm going to close it. Okay, so let's go ahead and here we are in Jupyter Lab. Let's open a Jupyter notebook. And I'm just going to go to File, New Notebook. And for the kernel, yes, I'm going to use conda-python 3. So select that kernel. And the first thing I'm going to do is I'm going to give this notebook a name. So it's an IPython notebook, as you can see. So, but let's give this notebook a good name. So let me rename it to something like say I'm gonna call this SageMaker underscore the algorithm. I'm going to use this XGBoost, as you will see in a few minutes. And I'm applying this to the PIMA data set, which we're gonna talk about in a second. So SageMaker XGBoost PIMA, okay? All right, so that's a good name right there. All right, perfect. So this Jupyter Notebook, it has like one code cell. If you want to add more code cells, you can use this plus option here. So we're gonna use a bunch of code cells. And if you ever want to change a cell from code cell to text cell, you're going to do something like this. Instead of code, you're gonna select markdown, okay? And now that's a text cell where you can add text, okay? Um, for example, right now I want to add a text kind of indicating what I'm doing. I'm gonna start by loading the data. So, okay, so that's a text cell indicating what I'm doing, loading the data. All right. Okay, let's do that. Let's load the data. Um, the data we're going to use is about the onset, as I said earlier, of type 2 diabetes, specifically in female members of the Pima tribe. Pima is a group of Native Americans living in Arizona and New Mexico. And what we want to do is we want to predict if a female from this group will develop type 2 diabetes in the next 5 years using information like kind of medically relevant information from that person, like the age, BMI, glucose levels, stuff like that. Okay. So we're facing a binary classification situation where the target variable has two possible outcomes. One, that means the person will develop diabetes. Zero, the person will not develop diabetes. Okay. Okay. Um, so the data is in URL. Okay. And as you will see throughout this notebook, I saved the code for certain sections in this Google Doc, just because, for example, for the URL, I don't want to memorize the URL where the data is, so I save that here. And also, for example, these are the column names that I want to use for the data frame that I'm going to create. I don't want to memorize that. So certain things I saved in this Google Doc. Okay. Anyway, so the data set is in this URL. It's a CSV file. It's a CSV file of Pima Indians diabetes. And yeah, let's use pandas. Let's use the pandas library to be able to read that CSV file into a pandas data frame. Okay. And yeah, let me, now that I'm here, let me go ahead and copy this. Control C, and I want to paste this right there. And let me go ahead and run this code cell, control enter. Okay. Now we have a variable with the URL address and then the column names. But we need to import pandas, right? I said I want to use pandas. So let's go ahead and import the pandas libraries as PD. And every time I import pandas, I also import NumPy. I don't need NumPy right now, but I will soon. So let me just do that right now. Import pandas as PD, import NumPy as PD and as NP. That's good. And all right, so let's use pandas to read the CSV file into a data frame. So PD pandas, I'm gonna use the method read underscore CSV. The first argument is going to be the URL. Okay, it's the first argument. The second argument is just to specify that for the header, I want none. I don't want to read the header. And for the column names, I want to specify for the names parameter that the names parameter gives the data frame column names, and I store those column names right here. So for the names, I want to use the column names that I save. There you have it. All right. And does this look good? Yes. So those are the three arguments I'm going to pass. And obviously, I'm going to store this in a data frame. So let me call this data frame something like Pima uh, diabetes DF or something like that. That's a good name, Pima's diabetes DF. And let's run it and let's take a look at the data frame. Let's take a look at the data frame using the info function. And notice that we have data about 768 um, female PIMAs, okay? And so for each person, we have information about the number of pregnancies. Pregnancies means the number of pregnancies, okay? Glucose level, blood pressure, and so on and so forth, age, and finally the target. The target is whether the target records whether the person has diabetes or not. Let's take a look at the target. I want to take a look at the frequency distribution, like how many ones and how many zeros. Okay, how many persons with diabetes, how many people without diabetes. Okay. Um. Okay, so I'm gonna specifically retrieve the target. Target is just the last column right there. Target. Okay. I'm gonna retrieve the target, and on that column, I'm gonna apply value counts just to see a frequency distribution for the two classes. Um, okay, so it has to be PMA like that. And as we can see, oops, value. I always forget it's values, value count. Sorry, I was missing an S here. So there you have it. A value count. So I always forget is it values count or value count? Yeah, I always forget it's value counts. Anyway, so as you can see, we have 500 people, like 500 people belong to the zero class, so 500 people do not have diabetes, and 268 people do have diabetes. So 268 people belong the to the positive class. Okay, so and if you want to get the percentages, which might be helpful, not necessary to do, but maybe you want to get the percentages, you can use that parameter, and you can see that we have 65% of the observations belong to the negative class, 35%, almost 35% belongs to the positive class, okay? That's a somewhat unbalanced data set, but that's all right. All right, let's go then. We have the data ready. Now we need to start doing some pre-processing steps. The first pre-processing steps we need to do is the following, guys. The algorithm that I'm going to use to do the classification is XGBoost. So it's one of the kind of signatures algorithms for classification in SageMaker. XGBoost. That means extreme gradient boosting. That's just SageMaker version of boosted trees. So we all know boosted trees as a technique, right? Well, SageMaker's kind of advanced application of boosting is XGBoost. Okay. Now, XGBoost requires the target variable to be, it's a requirement. It requires to be in the first column. The target variable must be in the first column. Okay. Right now it's in the last column, so we need to change that, all right? There are countless ways of doing that. I'm gonna apply a way that I have always applied, which is I create a column list and then I change the order of the columns in that list. And then I use the list to re-index the data frame, okay? So it's just one of the many ways that you can use. So I'm gonna create a column list with the columns of this data frame. Um, Diabetes, DF. I'm gonna retrieve the columns and I'm gonna uh, change them into a list. That should work. Sure enough, now I have a list with the columns. And what I'm going to do is I'm going to change the order. So I want target to be the first element of that list. So I'm going to retrieve target first. So from column list, I'm going to retrieve target. Okay. So I'm going to slice the list in two different ways to retrieve the target first. Okay. That should give me the target only, yes. So, but I want to concatenate that with with a list including including from index 0 to the second to last index. So -1, that is going to exclude the -1 is the last index. So that is going to go from index 0 to -1. Okay. Um, to one last, sorry, one before -1. -1 means the last index. So one before the last index, that's what I want. Okay. Actually, let's confirm that we get what we want. Yes. So we go, here we get target first and then pregnancy, all the way to age. Yes, that works. And what I'm going to do is I'm gonna assign that back to column list. Okay, so column list. So now our column list will consist of that. And then what I'm going to do is, and again, guys, this is just one of the many ways of doing this. What I'm going to do is I'm gonna index the PIMA diabetes DF with this new column list, okay? And I'm gonna reassign that back to PIMA diabetes, all right? So now I'm gonna reassign PIMA's diabetes with this new order to PIMA's diabetes, and that should work. Now, if we take a look at PIMA's diabetes, now we should see target first, then the rest. Yep, target first, and then the rest. Good, perfect. So let's add a few more code cells here. So what else do we need to do? Um, So we need to do a few pre-processing steps, remember. So that's the first one. Now we need to split the data. In machine learning, we always split the data. Whenever we're training a machine learning solution, we split the data, either training testing or training validation testing, okay? Um, Many analysts will do the split into training, validation, and testing, but this is the thing. Validation data set only makes sense if you are tuning the hyperparameters of the machine learning algorithm that you're using. But here we are not, because in these videos, you will see later, I will use fixed and predefined hyperparameter values for XGBoost. So I'm not tuning or trying any different hyperparameter values. I'm using fixed values. So there is no need for the validation data set, okay? And so I'm just going to basically split into training and testing. I'm going to use the train part to train the model, and then the test part to evaluate the quality of the model on the test data. Okay. Okay. I'm going to do a split using a widely used function from scikit-learn, train test split. Okay. Well, not from scikit-learn specifically, from the model selection module in scikit-learn. So from scikit-learn, uh, specifically from the model selection module, I'm going to import the super useful function train test split. That's the one that is going to allow me to do the split, okay? Okay, so now I'm gonna use that function to do the split, okay? The functions takes a few arguments. The first one is what am I splitting? I'm splitting the data frame. The second one is, so what is the training size and test size? To that, I'm going to use test size. I'm going to specify the test size, and doing that, I specify the training size as well. The test size is 0.2, 20%. That means I'm going to devote 80% to training, 20% to testing. That's the most common split. Okay, you can use a different one, but that's the one I'm using. I'm going to control the randomness by setting the seed to 1. Remember that this split is random, so the observations selected for training and testing are randomly selected. If we don't control the randomness, which is what I'm trying to do here by setting the seed to 1, then you guys are going to get different training and testing data that I will. And, it will be messy because it will be hard to explain the results, okay? And so for reproducibility, I'm going to control the randomness, okay? And the final argument, and this is really kind of optional, but I like to do it. It's a good practice. I'm going to set a stratify to, what is this stratify? Let me explain what this means. Remember that in the whole data set, we have 60% of negative observations, 35% of positive ones. If you want to keep those same percentages, okay? If you want to keep those same percentages for both classes in the training data and in the test data, okay, which is, I think is a nice thing to do in most cases, anyways. One thing that you can accomplish that is by setting a stratify to uh, to the target variable from the original data set. So if you set a stratify to the target variable, target column from the original data set, the frequencies in that target column will be applied to the training data and test data. Okay, so let's set a stratify to PIMA diabetes DF specifically to the target column. Okay, target Is this correct? Let me check my spelling here. I think it's fine. And yeah, obviously, but then obviously I need to, because I'm creating a training data and a test data. So I need to assign this. I'm going to create a train data frame. So I have the full data frame, but I want to create a train data frame and a test data frame. Okay. And that should work. Yep. Now let's take a look at train df. It's just a data frame with 80% of the observations. 614 observations, yes. And then the test df, it will be a data frame with the test observations, okay? Yeah, 100, 154 observations. Good, good. What else? What else? What else? So another pre-processing step. So we need a bunch of pre-processing steps, guys. Okay, so let me have both cells. We need a bunch of pre-processing steps before we're able to apply XGBoost. The next pre-processing step is the following. The XGBoost algorithm, which, as I said, is the algorithm I'm going to use to do the classification of solution or to obtain the classification solution, um, must load the data from Amazon S3. So the data to feed the XGBoost algorithm must live in S3. What is S3? That's Amazon Simple Storage Service. So it's just an app. It's an AWS app to store data. Okay, so SageMaker is for doing machine learning things. So S3 is to store data. Okay, XGBoost requires the data uh, for training to be there in S3. So we need to move the data from the notebook instance to S3. Okay, and another requirement is that the data in S3 must be in the right format. Okay, the preferred format for XGBoost is CSV, okay? CSV file. So we should have a CSV file with the training data and another CSV file with the test data, okay, in S3. So let's take care of that right now. Let's take care of both converting the data into a CSV format and then sending that data to S3, okay? Now, since I'm going to repeat the process of converting data to S3 and then send it I'm sorry, converting data to CSV and then sending it to S3. I'm gonna repeat that many times in this notebook or in this video. I created a function to that. Okay, so like in programming, whenever you need to repeat the same operations again and again, it's better to encapsulate that in a function, and that's what I did. Okay. Um, that's one of the code that I included here. I don't want to memorize, obviously, all of that code. So that's the code that would allow us to do both the upload to S3, as you can see, and to convert to CSV file. Okay, so let me copy that from here. I'm gonna explain this in a second. Control C and Control B, Control B. There you have it. Okay, and so enter, and this is good now. So let me explain a few things about this function, okay? So first, let me explain the argument. So it takes three arguments. Folder, folder is just a folder name of the folder in S3 where you want to store the data, the CSV file. So we're gonna have a CSV file, and we want to store that CSV file inside a specific folder. That's the folder name. File name is just the name of the CSV file that we want to create and then upload to S3, and data frame is just the data frame that we are converting into a CSV format. Okay, it could be the data frame with the training data or the data frame with the test data. If you had a validation data set, it could be the data frame with the validation data. Okay, so whatever data frame you are sending to S3 and converting to CSV file. Now, in terms of the function, I'm sorry, in terms of the body of the function, like this code right here. So this part right there, as you can see, that creates a buffer, right? So it's a buffer in memory to kind of temporarily store the CSV file data as a string, meaning like, instead of saving the CSV file locally in the notebook instance, we write the CSV file temporarily to this buffer, and then we send it from the buffer to S3. we have no need at all to have the CSV file stored locally in our notebook instance. We don't need that at all. We need our CSV file on S3. So the most efficient way is to do it like this via this temporary buffer. Okay. All right. So then the next step is, we take the data frame and we convert it to CSV file and we store it in the buffer. Now this step key here, we are kind of creating, as you can see, a path using the prefix, folder, and file name. So what are these? Well, so let's try to understand this path. Well, we understand this, right? Folder and file name. These are just, right, the folder and name that we enter as arguments. Folder and file name, right? Now, what is this guy right here? Prefix. Well, that prefix, guys, is the second folder. Okay? It's the second folder, which is optional. That second folder is optional, but it's recommended. Okay. What do I mean by that? That prefix is usually the folder with the name of the project, kind of the overarching folder, okay? So inside this project folder, maybe we want to have a folder with the training data. Maybe we want to have another folder with the test data. And maybe we want to have other subfolders, you know what I mean? So it's recommended to have an overarching folder with the project name, okay? And that's prefix, all right? Again, this is not mandatory, but it's recommended. Cool. Now the last line. So I guess it's kind of simpler to break this down by fragments. So what is this S3 object? Okay, I created this S3 object right here, as you can see, right? Um, Here, as you can see, I'm using the Boto3 module, which I imported right here. And what is this Boto3 module, guys? Well, very important module. That's the module that allows the Python code in our notebook to talk to AWS. Okay. So here specifically, we are using Boto3 to connect the code in our notebook to this specific service, S3, the S3. Remember, S3 simple storage service. And yeah, so this S3 object variable kind of creates a connection between the code in our notebook and S3. And it would allow us to, like, thanks to this variable that creates a connection, we're going to be able to, like upload data to S3, download data from S3, delete data in S3. So that's a really, really useful variable. Okay. All right. So how about this now? Like put object, and then here we have something that is bucket. Let's understand this. Here, guys, we are accessing a specific and predefined bucket. And what we are doing is we are placing an object. That's the way we call files in S3. Instead of files, we call files objects in S3. So we are placing an object or a file in that path inside that bucket. Okay. Now, what is a bucket? I haven't talked about this yet. What is a bucket? Well, that's something very specific to S3, guys. In S3, they say that a bucket is a container. So they don't call a bucket a folder. They say a bucket is a container that contains all the files and all the folders that you want to create in S3. Okay. So it's kind of mandatory. Like if you want to use S3, you need to define a bucket. And once you define a bucket, you can create all the folders and all the files that you want inside that bucket. Okay. It's kind of the overall container. Okay. And this is something that we need to define. I will show you how to define that bucket. So you need to use a predefined bucket. We'll show you that in a second. Um, what else? What else? What else? So as I said, we are placing an object, a file inside that bucket, and this body parameter kind of defines how or what specific file we want to create in that bucket. Okay. Notice that here we are invoking from the buffer the get value method. Okay. By invoking the get value method on the buffer, this is what we are saying. We are saying, hey, to create the CSV file, we only want to get the value. Get value will only get the value from the buffer because the buffer also has like metadata associated to it. We don't want any metadata from the buffer. We only want the content from the buffer. So if you want the content, you need to use the get value. Okay. And that's the way we create that CSV file. Okay. All right. So now let's go ahead and use this function to upload. Uh, Now for now, I'm gonna upload only the train data frame. I only need to upload the train data frame and create the train CSV file. I don't need the test right now. We could, but we don't have to. So I'm gonna just do it step by step. So I'm gonna only create a CSV file with the training data and upload it to S3. Okay. Now I told you that to use this function, we need to pre create a bucket, right? We need to use a bucket, which is the overarching container in S3. Um, so for the bucket, and this is kind of there are many ways of creating buckets in S3, but if you're using SageMaker to do machine learning, which is what I'm doing right now, the easiest way, guys, is to use the default bucket from SageMaker. So SageMaker as an app has an assigned default bucket in S3. You know what I mean? SageMaker as an app has an assigned default bucket in S3. So let's use that bucket for this demonstration. Okay, so let's use that bucket for this demonstration. So what I'm going to do is I'm going to retrieve that predefined bucket. Okay, so and to that we need SageMaker. Have I imported SageMaker yet? No, I haven't imported the SageMaker module yet, right? No, so we need to import SageMaker, and then from SageMaker we need to retrieve that bucket. So let me import SageMaker. We haven't imported SageMaker yet. And now from the SageMaker module, I'm one of the following. The way you import the default bucket from SageMaker is you invoke a session, and then you now can kind of retrieve the default bucket. Okay, as I said, wait, let me pay attention to this. So to check my spelling, SageMaker session default bucket. Yes. So as I said, SageMaker as an app has an assigned default bucket in S3. So let's just go ahead and use it. Okay, and that would be our bucket. So let's save this in bucket. You can use whatever name you want, but I'm just gonna use bucket. And yeah, that's all. So that should work. And yeah, it does. And we also need, guys, we also need a prefix. A prefix is kind of the overarching folder. Okay, so it's just a folder with with our project name. Okay, um, you can use um any name that you want for that um overarching folder. How am I gonna call this prefix? I don't know, like maybe something like this. Again, I'm just struggling to find a good name, but maybe I'm gonna call this SageMaker, kind of similar to what's a good name for that overarching folder? SageMaker XGBoost, P my example, something like that. Maybe like that. Okay, SageMaker XGBoost P my example. That's kind of the overarching folder, like the folder with the project name, and then we're gonna have inside the folder the training folder, the test folder, and so on and so forth. Okay. Okay. This is good. Now that we have defined our bucket and our prefix, we can go ahead and invoke this function. Okay. Go ahead and invoke that function with specific arguments, guys. Um, The first argument is the folder, the name of the folder. So I am uploading the train df. So this is going to create the train CSV file. So the folder name that I want to use, and this is optional. You can use whatever name you want, but try to use a good name. It's train will be the name of the folder. So inside this folder, SageMaker XGBoost PM example, I'm going to have the train folder. Okay. Then is the file name. Aren't we creating a CSV file with the training data? So a good name, not the only possible name, but a good name is train.csv file. You need to specify the extension, okay? You need to specify the extension. And again, you have some freedom here to decide your name. So I think these are good names. And the data frame, here we have no freedom. The data frame that we are uploading is the train df, aren't we? And yep, let's go ahead and do it. So let's run this, Control Enter, and then whoop, it worked. So now we have a CSV file. Even if we cannot see it, I mean, we can go to S3 and check, but even if we cannot see it right now, uh, on S3, on this bucket, on this specific folder, and inside the train folder, we have a train CSV file, okay, with the train data. Cool. We're almost there, guys. We're almost there. What else do we need? What else do we need? We need to create now a data channel. Okay, we need to create a data channel. And I think I have the code for the data channel here because it's kind of annoying to remember this. Oh, look at this. I forgot I had I have this saved here. Anyways, so it's very similar to the names that I use here. But anyways, I forgot I had this here. No, I just want to check if I have yes, I have the code to create the channels. Um, okay, we need to create something called data channels. Okay, data channels. Let's, you know what? Let me add a few text cells kind of to help you understanding what we're doing. So data channels. I just noticed that maybe I want to add a few code text cells. So here we're loading the data. Um, here we are splitting the data. I'm gonna add a few code text cells here, guys. Okay, split the data just to help you a little bit. Split the data, and here add another one saying something like send data to S3 and convert to CSV format, something like that. Okay. And then after that, we're going to create the data channels. What are these data channels, guys? So it's a very specific requirement from XGBoost. Okay, actually from SageMaker. It's a requirement from SageMaker. So whenever you want to run what they call a training job, so whenever you are feeding a machine learning solution, you need to run a training job to train that machine learning solution, right? So whenever you need to do a training job in SageMaker, they require us to define a data channel, okay? A data channel, and what they say, like when they define data channel, they say that a data channel is a named data stream. So when you look for the specific definition of a data channel, they call it a named data stream. So, but more concretely, what is a data channel? Data channel connects a file, okay? In this case, the CSV file on S3, right? The CSV file on S3 that we just uploaded, right? So it's a connection between a file and the data source expected by SageMaker. So SageMaker expects a trained data source for sure, that's mandatory, and sometimes a validation data source. Validation data source is optional, but for sure, SageMaker expects a trained data source. So a data channel is a connection between a file on S3 and that expected data source. Okay. Here we don't have a validation data set, so we don't need to create a validation channel, but we always must create a train channel. Okay. And yeah, let's go ahead and do that. Let's create the train channel. Again, guys, if you have a validation data set, you need to create a train channel and a validation channel. We don't have to create a validation channel because we don't have a validation data set. All right, let's do that. One more thing to know is that a data channel must be defined as a dictionary. Okay, so that's a requirement. So a data channel must be defined as a dictionary. So yeah, as I said, and I showed you earlier here, I have already the code to that. I don't want to remember all of that code. So that's the way we create the data channel. Let me show you. Control C, and there you have it. Let me run it, and then I can explain it. So Control Enter. So notice that, as I said, the data channel must be a dictionary. Okay. So train, this is the train channel. And the train channel is just creating, using that function training input, is creating what? A map from the file in S3. That's the file that we created in S3 and the expected training data. Okay. So yeah, that's the train channel requirement. Again, it's just a requirement in SageMaker. And now we are ready to define um, kind of create our model. Okay, so now we're going to use XGBoost to create our model. Okay, um, so let me add here kind of text indicating what we're doing. So um, let's say this. Let's say we're defining the model now. Now one more thing before we can actually define the model is to know that SageMaker, and this is something that you need to know, SageMaker, uh, when it comes to training a model, that training happens in containers. Again, it's a requirement. So, and it's a good requirement because it's very good that that's the case. Um, yeah. So SageMaker jobs, when it comes to training a machine learning model, um, they run in containers. Okay. What is a container? Remember, a container, it's like an environment that includes everything needed to run one specific application. In this case, the application that we want to run is the SageMaker XGBoost algorithm. So for SageMaker, for the SageMaker XGBoost algorithm to run, we need to have the code for the XGBoost algorithm itself. But we also need all the libraries and all the modules needed as dependencies to run that algorithm. So for XGBoost to run, there are certain dependencies that needs to be executed, right? Well, the container will take care of all of that, okay? So to retrieve the container specifically for XGBoost, we are going to use a module available in SageMaker, which is image URI, okay? That will allow us to retrieve the container for XGBoost. But if you need a container for another algorithm, like there are many algorithms in SageMaker, like linear learner, that's another algorithm. So you can retrieve the container for that specific algorithm as well. Okay. Anyway, so let's retrieve from the SageMaker. So from SageMaker, specifically from the image URI, URI, is it? I guess we can check. I remember if it is singular or plural, we can check. So from that module, we can import the retrieve function. So this retrieve function, that retrieve function will allow us to retrieve the container for the specific algorithm that we want. Again, in this case, we want to retrieve the container for XGBoost. Okay, let's see if this works. No, but the problem is SageMaker. I missed an A, so SageMaker. And yeah. So I remember I wasn't sure. Is it singular or plural? So we're getting an error here. So it should be plural. So URIS. Okay. And yeah. Okay. That was a problem. All right. So from that module, we can retrieve or we can import that function, retrieve function to retrieve whatever container that we want. Okay. Now the container that we want is a container for XGBoost. So we're gonna do the following. So we're gonna retrieve and this function takes a few arguments. The first argument is what is the framework, what is the algorithm that you're retrieving the container for? So it's XGBoost. Okay. So we're retrieving the container for XGBoost. Check spelling. Yes, that's good. Next, and this is a requirement, guys. Um, in SageMaker, when you are using resources, you need to define, like for certain resources, you need to, for all resources, but you need to specify a region. So SageMaker, not SageMaker, but AWS works in many regions in the US and in the world, okay? And so you need to assign specific resources to specific regions. Like right now, I'm working on the East region from the US, okay? But like if you don't want to memorize that, you can specify that. Like now you need to specify a region. This is what I mean. You need to specify a region. You can go ahead and specify the region that you're working on if you know it, okay? But a kind of easier way is to retrieve that region automatically. So from bottle 3, remember that module that we um, imported earlier? From bottle 3, you can say, from my session, from a specific session that I opened, retrieve the region name, please. That's the easier way. Not the only way. If you know the region name, you can enter it as a string. That's fine. But I don't remember the region name. It's US East. But anyway, so that's a simpler way. Okay, so just retrieve the region name automatically like that. Um, what else? Oh yeah, another requirement is the version. Guys, this XGBoost algorithm has a bunch of versions. Okay, the one that I have been using is not the latest one, by the way. It's not the latest one, but that's the one I have been using is 1.2 hyphen 1. Okay. 1.2 hyphen 1 or dash 1. Um, Not the latest one, but that's the one I have been using. That's the one I have only used, by the way. So it works. So I'm gonna use that one, but you can check out the different versions and the difference and stuff like that. Okay. Okay. Obviously, I want to store that container once I retrieve it in a variable. I guess a good name would be container underscore XGBoost, right? Because that's what we're doing. We're retrieving the container for XGBoost, and this should work, folks. Yep, it worked. Okay. We have the container. Now we can run the XGBoost algorithm. One more thing that we need, guys. Actually, we need a couple of more things. So it's kind of tedious. So as you can see, it's kind of tedious to be able to run um, a model in. Well, I mean, it's tedious when you're learning. Once you know the steps, it's not that tedious anymore. But like if you're learning this, it's kind of overwhelming, okay? Because there are many requirements. So AWS has many requirements. Anyway, so two more things. Remember, I told you that we were using, right, specific hyperparameter values for the model, right? So if that is the case, you need to specify those hyperparameters. Okay, so let's go ahead and specify what hyperparameter we're using for XGBoost. Okay, and I'm going to define that. Well, that's a requirement. You need to define that as part of a dictionary. Okay, you need to define that as part of the dictionary. Again, we're doing this because we're using specific hyperparameter values, so you need to define them. Okay. So let me create a dictionary with these hyperparameter values. We only need to define how many? Three of them. Okay. Uh, Let me call this dictionary hyperparams. Hyperparams. Maybe a little bit more. Hyperparams XGBoost. XGBoost. Uh, yeah, yeah. Hyperparams XGBoost. That's good. That is a good name. And let's create a dictionary with the hyperparameters. So we need to define, it's mandatory to define these three hyperparameters. The first one is something called num round. Let me type it first. Is it num or num? I think it's num round. Yeah, num round. And guys, that is just kind of the number, okay? The number of boosted trees in your boosted solution. So how many boosted trees do you want to include in your boosted solution? If you have ever used boosting from scikit-learn, from Python scikit-learn, you will remember the hyperparameter n underscore estimator. That's the number of trees in the boosting solution. Same thing. Num round is the same on n estimators in scikit-learn, okay? And for that, I'm going to use a kind of standard number of trees, which is 50. Okay. So you can change that. Okay. But I'm going to use 50. You need to enter that as a string. Okay. So even if it is numeric, you need to enter that as a string. So I'm going to use 50 trees. You can change that. Okay. But that's all right. I'm going to use that. The second hyperparameter is how do you want to evaluate your model? So the evaluation metric, and here you can do, here you have a lot of options. You can read the documentation if you're interested, but you have a lot of options, guys. So like the error, so do you want to use as an evaluation metric the error rate? And that's fine. You can do that. I'm gonna use AUC, area under the curve. Okay, area under the ROC curve, okay? But you can also use the error. That's fine. And the third argument that we need to specify is the objective function, and this is also mandatory. Objective function. And for the objective function, I'm gonna define binary column logistic. Well, binary is obvious because, right? The target has two possible classes, right? 1 and 0. So that's why I'm saying that the objective function is for a binary solution. And logistic, just because we want to convert the raw numbers or the raw scores returned by the set of boosted trees into probabilities. So if you read about boosted trees, you will see that a set of boosted trees will return a score. We want to convert that score into probabilities, so we can use that probabilities to make a decision. You know, like if the probability is more than 0.5, then it's 1, otherwise it's 0. So we need to convert the raw numbers returned by the boosted trees into probabilities. So that's why I'm saying logistic, because we want to apply the logistic function to do this conversion. So we want to convert the raw score into probabilities using the logistic function. Okay, that should work. Yeah, perfect. Now one more thing. I said we need a couple of more things. So we need to define also uh, or specify a location, okay, a location in S3 to store the output files. Okay, so when you run a training job in machine learning, there will be a few output files, and we need to define a location in S3 to store those output files. What are the output files? The most common one is what they call the artifact or the model artifact. They call it the model artifact. That's just a file. It's a file that contains the parameters learned by the model, and that's a file that can be used to make predictions with that model. Okay, so when you run the training job, something called the model artifact, which is a file, will be saved. Well, you need to define the location in S3 where you want to store that file. Okay. Another possible, and it really depends on what you do. Another possible output file is a file storing predictions. So if we ever use this model to come up with predictions, um, um, that file can be stored. That file with the predictions can be stored in that location as well. So we have to have a location to store the outputs from this training process. Okay, and yeah, so that's a location in S3 that we need to define, and I have a code for that. Yeah, right there. Okay, as you can see, it's just a location in S3. And let's try to understand this. So that's the location in S3 where I want to store the output files, and that would be inside my bucket, the bucket that I defined earlier, inside the prefix. That's the overall, oh, sorry, the overarching folder, right? Inside that, I'm going to create a folder. So that output files is a folder where I want to store the output files. Okay. So let me copy this. Copy that. Guys, this is another requirement. So that is another requirement, you know. So we need to define, uh, actually, let me explain that here so you understand what is going on. I'm trying to make the video as short as possible, but I also want to explain a few things. So next, we define the location in S3 with the output files, okay? All right, great. Again, that's it. That's a requirement. Otherwise, you cannot run cannot run a training job. Okay. Now we are ready to define the model, guys. Now we are finally ready to define the model, and for that, I'm gonna add a few code cells here. So how do we define a model, guys? How do we define a model? So from SageMaker, we need to use the estimator. Uh, we need to use the estimator function. Okay. So using the estimator function, we can define a model, and then we can fit that model to the training data. But to define a model, in this case, we're going to define a model that will apply the XGBoost algorithm for a classification task. To do that, you need to use the estimator function, okay, which is part of SageMaker. So we're going to say from SageMaker, from the estimator module, from the estimator module, retrieve the estimator function. That's the estimator function. That is the one that is going to allow us to define our model. And I'm gonna obviously, let me do it right now so I don't forget. I'm gonna obviously store that in a variable. That will be our model. So I'm gonna call this I'm gonna call this XGB, meaning XGBoost model. Okay. XGBoost model. Now this takes a bunch of parameters as you might expect. So first one is the um and here I'm always confused. You remember also I wasn't clear, like I don't remember why, because the module is image URIS in plural, but this parameter is in singular, if I remember correctly. So one is in plural, another one is in singular. So here the parameter to define the container is in singular. Okay, so that's why I was confused. Anyway, so that's the container. The container is this container that we specify here. Okay, so B. Um, Next argument is a role. A role, guys. What is a role? Any job, specifically a training job in SageMaker, requires what they call an identity and access management role. Identity and access management is another app, it's another service in SageMaker. Um, so it's mandatory. So any training job must be attached to an identity and access management. So we need to assign an identity and access management role to this notebook instance, or otherwise this notebook instance will not be able to communicate with SageMaker or with S3, okay? So once we assign this role, then the notebook instance will be able to, like it will have permissions to access the data in S3 and interact with S3. So it's mandatory. So we need to assign a role to this training uh, process that we're doing. Okay, so that's the role parameter. And to assign a role, guys, the easier way is to retrieve the role automatically from SageMaker. We can use this function get execution role. Like give me permissions to execute this training job, please, so I can access the S3 buckets and folders and all of that. Okay. So that's the easier way. Let me check my spelling to get execution role. Yes, I think that's good. Yeah, that's good. Another thing that we need to specify is why don't I just kind of move this down because it's gonna be very, very inconvenient to have like a very long line there. So another parameter is how many instances do you want to use, right? How many computing instances do we want to use? In this case, we only need one, guys, okay? We only need one. So you can read about this, like when do I need multiple instances to run a training job? So you can read about that, but in this demo, this is just a demo. One instance is okay. Another thing that you need to define is the instance type. This is just another there's a sea of information about the instance types that you can use. SageMaker has so many instance types, so you can read about that, okay? But I'm gonna use the one that I always use whenever I want to run XGBoost, and it really depends. It really depends on the algorithm you're running. But whenever I'm running XGBoost, I use this type of instance, ML M4 dot X large, okay? Again, guys, so if you want to understand the different type of instances and the application, please go ahead and read more about this in the SageMaker documentation, okay? But that one will work, okay? That one will work for sure. So another thing that we need to specify is what is the output path? So wait, let me finish this and then I talk. Output path. Where can SageMaker store the output files? I'm asking you that. Where can SageMaker store the output files? Didn't we define that right here? So it's right here. So the output path would be that location, folks. Okay, cool. Another thing is didn't we define the hyperparameters? I told you that since we were using specified hyperparameters, we need to define this, right? So, well, there is a parameter here for the estimator function that is hyperparameters. What are the hyperparameters? And obviously, you can define all of that. You can define all of that here, but it will be very crowded. Okay, so that's why I define the hyperparameters in this dictionary right here. So I'm gonna say, oh, the hyperparameters will be my dictionary hyperparameters XGBoost. Okay. Uh, what else? One more thing. Yeah, the last thing, guys. In addition to a role, okay, whenever you are running a training job in SageMaker, you need a role and also a session. A session allows the notebook, the instance notebook, to talk to SageMaker. So for the notebook, for the instance notebook to be able to start the training process, because we want to start the training process from this notebook, right? For the instance notebook to start the process, it needs to communicate to SageMaker. And the way of doing that is to embed the instant notebook in a SageMaker session. So that's another requirement. We need to embed the notebook instance in a SageMaker session. Okay, otherwise the notebook instance will not be able to run the training job. Okay, so what SageMaker session are you going to use? And guys, again, the easier way of retrieving the SageMaker session is to do it. Use the default one, the default session. So from SageMaker, retrieve the current session. This will retrieve the current session. You know what I mean? That right there will retrieve the current session. That's the session that we want to embed the notebook in. Okay. So this should work. And am I missing something here? It says instance type. Uh, oh, right. Yes, 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 yes. I mean, sometimes the errors are self-explaining. Keyword argument repeated. Instance type and instance type again. This is not the instant type. This is the number of instances. So this is the instance count. Sometimes the errors are self-explanatory, guys. So now this should work. Yep, and it does. Okay. Now, here I just defined the model. Okay. I haven't run the model. So we need to fit the model to a training data now. Okay. So we need to fit the model to a training data. So what I'm going to do is I'm going to do fit, and then I'm going to fit the model to a training data, but we need to pass um, the we don't pass the training data. We need to pass the data channels, because remember our training data is already in S3 as a CSV file. So we need to pass the data channels. That's an argument. Um, okay. Is it channels? I always forget. Or channel? Yes, in plural, data channels. I mean, you can define this whatever you want. Actually, here it would have been a good idea to just call this data channel, because you only have one channel. Okay, so because you have several channels if you have validation and training, but here we only have training, so we could have called this data channel only in singular. Okay, so I'm gonna leave it like that, but just keep in mind that that S is unnecessary. Okay, because you only have one data channel. Just gonna leave it like that. One thing I like to do as well, this is optional, totally optional, is I don't want to see any logs, please. Logs, false. Yes, logs is just like the training logs. So like they are very long, very, very long, just like logs with the training progress. I don't want to see that. Okay. So if you want to just, leave it true, which is the default option. Okay. Now, guys, I'm gonna run this. This is gonna take like a few minutes. Okay, so I'm gonna stop the video as the feed finishes, but let me run it first so you see how it starts. Okay, um, and just to confirm that we don't have any errors so far. So Control Enter, and yeah, so the training job is being created. So it started. Now it's gonna give me like a few information about the progress, but yeah, it's working. It's working. So I'm gonna pause the video, and after this is done, I'm gonna return. Okay, perfect. All right, the training job completed. It only took like 2 minutes. Okay, that's perfect. So we train an XGBoost algorithm with the training data to classify whether a person will develop diabetes or not. Perfect. So now let's do the following. Let's use that XGB, sorry, XGBoost model that we trained, right? Let's use it to predict the test data. Okay. Remember, we have a test data. So let's go ahead and do that. Okay. Let me actually add a text cell right here, kind of indicating what I'm gonna do. Use XGBoost uh, model, let's say, to predict the test data. Okay, great. All right, so how do we do that? To predict in general. So to use a SageMaker model to predict, we have two options. Okay, to use a SageMaker model to predict, we have two options. Either we create an endpoint and send predictions to that endpoint. That's way number one. Or we can create what they call in SageMaker a batch transform operation or batch transform job, and then make predictions using that batch transform. In this video, I'm going to use an endpoint, the endpoint uh, version. Okay. So remember, what's an endpoint? It's just like a URL where you host the model. Okay. So with an endpoint, we allow external applications to send data to the model and then to receive predictions from the model. Okay. So we kind of deploy the model to an endpoint. And once that happens, other applications can send data to this endpoint to receive predictions. Okay. Now, as you will see in this video, I will use an endpoint in a very non-realistic way, okay? Because I will test the endpoint from the inside the notebook, okay, or from inside the notebook. You know what I mean? So I will deploy the model to an endpoint from inside the notebook, which is normal. That's the way it works. So you usually deploy your model to an endpoint using like a Jupyter notebook like this. That's fine. But then I will send predictions to the endpoint from the notebook as well. That is unrealistic. So you don't send predictions to the endpoint from the notebook, okay? That's not the way things work in real life applications. So in real life applications, in production scenarios, um, you send predictions requests to the endpoint from outside SageMaker. You know what I mean? Like from a website, from another AWS service. That's very common. Okay, but you don't do it from the same notebook. So you don't send the predictions. You don't send the prediction request from the same notebook. Okay. But guys, I'm using this unrealistic way because I want to show you how to deploy a model, but I also want to show you how to use it. Okay, so I can show you how to deploy it, but I want to show you how to use it. So I need to do it in this unrealistic way because it's simpler. Okay, it's kind of the simplest way of showing you that. Like if I try to use an external website or AWS services, it will be more complicated. Okay, so all right, so. How do we do this? So to use an endpoint, we need to deploy the model to an endpoint. So we do that by invoking the model, which is this um, XGB model. And guys, we can go ahead and use the deploy. So we can invoke the deploy function, okay, on that model. And that would deploy the um, the model to an endpoint. But obviously, we need to define a few things here. So the first thing we need to define is um, that endpoint will rely on an instance to on a computing instance to be able to receive the prediction request and then to process the predictions request, right? So we need to define that like how many instances do we want to use for that deployment? I'm gonna use only one, okay? And here the parameters is a little bit different. Like here it was instance count, but here it's actually initial instance count because that can change later. So that's why it's called count. That's why it's called initial. Okay. But yeah. Anyway, so I'm gonna use one. Okay. So only one for this demo. We also define the instance type, which is going to be exactly the same one as I use here, guys. Okay. ML M4 X large. Okay. And what else? We need to define the serializer. This is very important, guys. The serializer. Serializer. What is this, guys? This defines how the input data that we're sending to an endpoint should be um, formatted before being fed to the endpoint. You know what I mean? So how do you format the data you're sending to the endpoint before being fed to the endpoint itself? And the way I'm gonna use is the way I'm gonna define this is I'm gonna use SageMaker. SageMaker has a function that defines this serialization process. And here the data needs to be sent in CSV format. Okay, so for example, you can send the data as a data frame. As you will see here, I'm gonna send the data as a data frame, but that data frame will be converted into a CSV file before being fed to the endpoint because of this that I'm doing right now. I'm saying SageMaker from the serializer serializers module um, use the CSV. I think it's a capital letter here. Serializer function. Okay, so I'm using a CSV serializer in short. Okay, so that converts the input data, which again, the input data could be a data frame, a NumPy array, whatever. It's going to convert it into a CSV format before being fed to the um, to the um, to the endpoint. That's convenient because yeah, again, you just send a data frame and then that conversion will happen uh, in the background. Okay. Um, okay, so that should work. So it's gonna take a few seconds for this deployment to happen. Let me check my spelling, but I think everything is fine. SageMaker serializers and CSV serializer. Yeah, that should work. Otherwise, I'll get an error. So Control Enter, and I get an error. Oops, of course, XGB model, right? XGB model, Control Enter, and now it's telling us that that model um, is being deployed to to an endpoint. Okay, the model is being deployed to an endpoint. Um, in the meantime, let me explain what I'm gonna do next. This is gonna take a few minutes. So now we need to send predictions to that endpoint, right? So we need to send predictions to that endpoint. What I want to do is I want to send the test data, okay? So I want to send the test data, but I want to only send from the test data the features, right? Because that's what I need for predictions. I don't want to send the outcome or the target because the target is what I'm predicting. So I need to send um, the data only with the features, okay? So what I'm going to do is I'm going to create a data frame. So I'm going to use testdf. Remember, testdf is the data frame with the test data. I'm going to retrieve only the features from there, okay? Only the features. And I'm going to store that in a variable, and then I'm going to send that uh, to the um, to the mm, to the endpoint, okay? I should have, now that I'm thinking about this, I can't do that now. I should have stored this. Is more convenient. I should have stored this in a variable so I can use that variable to send predictions. So I should have done that, all right? I can do it again. So what I'm saying is I should have stored this in a variable so I can send it because this is only creating the endpoint, if you know what I mean. So this is sending sorry, this is deploying the model to an endpoint. But then the next step is I want to send predictions to that endpoint. The easier way of doing that is if you have this endpoint stored um, in a variable, so you can invoke the predict method on whatever you want to make predictions about. Okay, so what I'm going to do is I'm gonna save this. Um, and I'm gonna repeat this again, okay? I can pause the video, that's fine. So should I call this? Usually, you know what? Usually they call this, they do a distinction. They call this predictor. Predictor. Like when you read the SageMaker sample notebooks, stuff like that, they call the model, and then the deployed endpoint, they call it predictor. It's a kind of customary way of calling this. So let me repeat this again because I want to be able to use that variable to make the predictions. Okay, so I'm gonna pause the video and repeat this and start once this is finished. This is gonna take a few minutes. Okay, but let me pause the video and resume. Okay, all right. All right, so the deployment is completed. So the deployment took around 5 minutes. So whereas the training only took like 2 minutes, the deployment took around 5 minutes. And remember what I was doing, I just noticed that it's kind of customary to store the result of the deployment in a variable, in this case, XGB predictor, uh, because now we can use that variable to send predictions to that deployed model in that endpoint. You know what I mean? So it's more convenient to now send predictions to that endpoint by using this variable. So always store the output from your deployment in a variable. Okay. As I was telling you earlier, so one thing that I need to do is because what I want to do is I want to create a data frame only with the features, right? Because that's what I want to send for prediction. So from the test data frame, which we created earlier, I'm just gonna retrieve the features. Okay, so to that, what I need to do is I need to leave the outcome out. So I'm gonna go when it comes to the columns, I'm retrieving from index one all the way to the end. So I'm leaving out index zero, which is the target. Okay, so that should give me only the the features. Okay, so I'm gonna store that in a variable. I don't know. Let me call this test df features or something like that. You can use whatever name you want, but I'm gonna use that name and test df features. And yep, sure enough, you see that we're fine. So here we have only the features. Okay, so we don't have the target. That's good. Now, what I'm going to do is I'm going to use this variable with the store deployment. Yeah, and I'm going to invoke predict. That's what I wanted to do. I wanted to be able to invoke predict on that variable. Okay, predict. What am I feeding to predict? This. Okay, and yep, let's take a look. Should take a few seconds to do that, and yep, Control Enter, and well, 1 second. It took 1 second. So this is the output from prediction. So notice that so the output returned by predict is what they call a byte string. Notice that B? That means that's a byte string. That's a byte encoded string. Okay, so that's why we see that B. Now, as you can see, these numbers are probabilities, right? So probability number one, comma, probability number two, and so on and so forth. So what probabilities are these? So these are the let's say these are the predicted probability that each test observation belongs to the positive class. Remember, we have two classes. One, the person has diabetes. Zero, the person doesn't have diabetes. So this is the probability that each test observation has diabetes, okay? And why? Why do we have probabilities here? Well, remember that we use, for the objective, we use binary logistic. Remember that? And logistic means that we wanted to convert the raw scores from the trees, from the boosted trees into probabilities. So we have probabilities. Great. Now we need to convert this into a usable format. We don't want to deal with by string, especially if we want to kind of create a confusion matrix with the results and all of that, which I want to do. I want to get a confusion matrix and all of that. So we need to convert this into a more usable format, like a data frame or not a data frame, but like a column from a data frame, a series or an array or a list. So something more usable. Um, so these numbers are probabilities, right? So maybe it's a good idea to convert this to create from this byte string, we can create a list with float numbers. Float because these are probabilities, so they have a fractional part. So I think a good idea is to convert this uh, into a list with float numbers. So I'm gonna do that conversion in 2 steps. So first, I'm going to convert the byte string into a string. All right. So let's go ahead and do that. Let's decode this to convert this byte string into a big string, all right? And the way of doing that is using using the decode function. So I'm gonna say I want to decode that byte string. decode and convert it into a string, okay, using this convention, UTF-8. Okay, so that is going to convert the byte string into a big string. And yeah, let's take a look. Let's take a look at this. And yeah, uh, yeah, there you have it, right? So here we had a byte string. Now we have a big string. Okay, that's a big string. It starts here and it ends right there. Okay, so actually, you know what? Let me go ahead and why don't I store this in a variable so I can keep processing it? Okay, so I'm gonna store this in a variable because I'm gonna call this decoded predictions. Why not? That's a good name. Okay, so I'm gonna store that big string into that variable decoded predictions. Now, what I'm going to do is I told you I wanted to have a list, right? With floats numbers. So, well, I'm going to um, convert that big string that I show you into a list. One easy way of doing that is by using a split. Okay, so let's just split. Well, we can use split to create a list, and then we can use our like list list operations to create the flow. Okay, but how do we get? Let me show you. How do we get this big string into a list? Well, the split function, guys. So remember the split function. Don't forget the split function. Okay. So if you do a split based on on the comma, right? And split based on the comma. That's the character I want to use to split. And sure enough, what do we get? We get this big string into a nice list of strings. Okay, that's good. So one more thing that we need. So we can now go ahead and I'll remove this uh, clear set up. I don't want to see this. Well, let me leave it there for you to see, okay? But it's kind of long. It's a long output. Anyways, kind of annoying, but that's okay. So that's a nice list. What I want to do now is, yeah, that's perfect, but that's a list of strings. I wanna have a list of floats, okay? Uh, well, we can use um, this operation, remember? And say something like I'm blanking of the name. I'm trying to remember the name of this operation with list. I cannot remember, but that's okay. It's not list enumeration. I forgot. Anyway, so what I'm gonna do is I'm gonna say, hey, um, traverse that list and then convert each element into a float. Okay. Oh man, I'm trying to remember the name of this operation. Anyway, so I'm gonna say, okay, traverse. I'm not gonna remember it right now. So I'm gonna say traverse that list. So for X or for whatever you want to call it in that list, okay, okay, traverse it and then convert each element into a float, okay. So traverse that list of strings and convert it into a float, okay. And obviously I want to store that in a new variable, okay. Now this list is going to have uh, these probabilities, but as float numbers, which is what I want, okay. So how did I call this? Decoder prediction. So I'm gonna call this list. Give this list a good name. I call this predicted because that's what we have. Predicted probabilities, predicted prob underscore test. So it's had the predicted probabilities for the test data. Okay. Um, all right. So Control Enter, and now let's check that we have a list of with float numbers. There you have it. That's what we wanted. So this was a list with the strings. Now this is a list with float numbers. So that is excellent. So let me remember this name right here. Because, well, first of all, guys, so notice that, don't forget what we did, because, I think you might have lost sight of what we did. So we deployed the model to an endpoint, right? That's that a step. Then we sent this data frame to that endpoint to get predictions, and we did. So we got those predictions, but we had to transform those predictions into a more usable format. Okay, created an endpoint, and then we sent predictions to that endpoint, and we got results. Okay, again, this last part, like you don't send in real life applications, in real life production scenarios, you don't send predictions from inside the notebook. You send predictions from outside SageMaker, from websites, from other services, or other SageMaker services, stuff like that. Okay. But anyway, so I just wanted to illustrate how this worked. Guys, what I want to do to finish this is, um, are the predictions good? Are the predictions good? Well, to know if the predictions are good, first we need to convert the probabilities into one of the targets. So either one or zero, okay? And so let's go ahead and do that. So what I'm going to do is there are half a dozen ways of doing that, but I want to use the operations in NumPy because NumPy has vectorized operations. So since NumPy has vectorized operations and lists do not, so what I usually do when I'm doing this is I convert this list into a NumPy array. Okay. So what I'm gonna do is I'm gonna use that list. Right now, this is a list. Okay. Predict proba test is a list. I'm gonna convert it into an array because I want to be able to use vectorized operations. You'll see what I mean in a second. So um, Control Enter, and now this is not a list anymore. It's an array. Okay, that's an array. Okay, and now, as I said, okay, these are probabilities. These are these are good, amazing, but we need predictions. So we need to convert the probabilities into predictions. And what I'm going to do is I'm gonna use the most common approach, which is I'm gonna compare the posterior probabilities, these are called posterior probabilities, with the most commonly used threshold, 0.5. So if the posterior probability is greater than 0.5, which is the most commonly used threshold, then I'm going to predict yes. Okay. So that's the most standard approach. If the predicted probabilities are, let's say, 0.5 or more, I'm going to predict yes. Okay. And or you can say more than 0.5. It's really not a big deal. Okay. But yeah, so and that's very easy to do using vectorized operations because I can do something like this. So if the predicted probabilities are above 0.5, and this is something that you can change. Okay. So you can use a different threshold if you want, but I'm going to use the most commonly used threshold. Um, well, what is going the output of that will be true or false. Okay, be true or false. So false when this is false, true otherwise. Okay. So what I'm going to do is I'm gonna um, encapsulate that or store that in a new array with 1 and 0. How do I do that? Well, again, many ways of doing that, but if you transform this into an integer, so NumPy will know that, oh, okay, false should be assigned a 0 and a 1 should be assigned, sorry, a false should be assigned a 0 and a true should be assigned a 1. So one easy way of transforming this into 1 and 0s is just by transforming this array uh, into int. Okay, guys, there are other ways. Okay, but this is just kind of an easy way. Okay, there you have it. So false to 0, true to 1s. Okay, and don't you want to save this in a new variable? Because I want to. I want to. So I'm gonna say okay. So uh, well, I'm not gonna call these probabilities because these are not probabilities. These are the classes itself, right? So guess I'm gonna call this predicted class. Test. Okay. And yeah, predicted class test would be an array with 1 and 0s. Okay. And now we can answer the question that I asked 2 minutes ago. So are the predictions good? Well, let's compare the predictions with the real values of the target. Okay. And to that, guys, I'm gonna do two things. I'm gonna do a confusion matrix and a classification report. I want to wrap this up now, so I'm not gonna spend a lot of time evaluating this, but let me just show you how to get a confusion matrix. So I'm gonna use scikit-learn, um, scikit-learn, and from scikit-learn, specifically from the metrics module, and I'm gonna import two things. So I'm gonna import a confusion matrix. matrix function and also the classification report. So you can see a classification report right there. I'm not gonna spend a lot of time explaining this. That's kind of beyond the scope of this video. But anyway, so uh, at least I wanted to show you, how do I check if the predictions given by the XGBoost algorithms are good? Well, just get a confusion matrix, okay? Get a confusion matrix here. So for the confusion matrix, we need to pass the a variable with the real values, with the actual values, and another one with the predicted. Do we have the real values stored somewhere? The real values of the target. Uh, mm, we don't. We can let's be organized. So let me add because confusion matrix takes two arguments: a variable with the actual values of the target and a variable with the predicted values. So we have a variable with the predicted values, right? So let me get a variable with the actual values. Okay. So instead of predicted, let me just say something like actual. Okay. And guys, how am I gonna get that from the test data, right? From test df, I'm gonna get the first column. Okay. From test df, sorry, I'm going to get all the rows and only the first column. So index 0 means the first column, okay? All right, and yeah, so that's from the test data, the first column, and that will give me the actual values of the target. Now we are ready. Um, what am I missing here? Oh, I need, yeah, of course. I guess the problem is, yeah. So to do the slice properly, I need to use what I did earlier. I forgot that. Every now and then I need to use ilog, right? Um, Yeah, that works. So, okay, now we're good. So, first argument is the actual values, and the second argument will be the predicted values. Okay, there you have it, folks. There you have it. Okay, that's the confusion matrix, and you can make this confusion matrix nicer. Uh, like if you wrap this into a data frame, it looks nicer. It's up to you. It's not a big deal. But if you wrap this into a data frame, it looks a little bit nicer. Okay, I want to do that. It's optional. But yeah, okay. So it's a little bit nicer because at least you see the labels. So um, true negative. So we have 83 true negative, 30 true positive. Okay. So these are false positive, 17 false positive. Okay. I'm 17. I'm 24 false negative. Okay. So that's nice. But like if you want more like numerical metrics of performance, you can use the classification report, and that's what I'm going to do right now. Classification report it's just a report with several metrics like the overall accuracy, the sensitivity, specificity, stuff like that. Okay, so classification report, and it's more convenient to it's more desirable to wrap classification report in the print function. Otherwise, you get a kind of a messy output. Anyways, that's your classification report, and here you can see more like more specific metrics, like this is the overall accuracy. So it's your XGBoost algorithm achieves a 73% accuracy in test data, not very good. The specificity is 83%. That's the recall for the zero class. Sensitivity 56%. That's a recall for the one class, not very good. Here you can see the one scores, the precisions for each class. Okay, so I'm not gonna get into this right now. Okay, so I'm not gonna explain how to interpret a classification report and what these metrics means. That's another video. Okay, but yeah, that's the way you get a classification report. And yeah, but overall the performance is not very good. Okay, just like that 73% accuracy seems pretty low. Obviously, we used this default hyperparameters. Remember that? When we define the model, we use these default hyperparameters. Like, what if we use different hyperparameters? We probably get better outcomes, right? Better results. As a matter of fact, you can in SageMaker you can do a tuning job to find the best hyperparameters, and I assure you, like if you use different hyperparameters, you're gonna get better results. So if you do a tuning job to find the best hyperparameters, you're gonna get better results, right? Okay, so let me go ahead and save this. Um, this notebook because I want to share this notebook with you guys, okay? In the video description. So let me do that right now before I forget. So that notebook that I downloaded, I'm gonna share with you guys. And yeah, that's all, guys. So I hope you enjoy the video. I hope you learn how to train a classification solution in SageMaker. I hope you learn a little bit about that the algorithm that we use, XGBoost. And yeah, thank you for watching. I will see you in another video. Bye.